Good morning, good afternoon, good evening, wherever you're watching from around the world. Welcome to today's webinar on VMware Tanzu RabbitMQ. This was actually part of a series. I believe this is the fourth part in the series. If you haven't watched the previous series or previous videos, don't worry. They've been recorded and they are available in the attachments tab, but I don't think you'll need to watch those to join in on the fun for today's event. So before we bring in our tremendous speakers, just want to go over some housekeeping items. First, we'd love to keep this as engaging as possible and as exciting as possible. So if you have any questions for us, please submit them below using the Ask the Questions tab. In addition, we know that you guys are here to hear from us. We would love to hear from you. So if you have any feedback or if you'd like to have a topic that you'd like to hear from us, please submit them using the Rate This tab, also below the presentation screen. Without further ado, let's introduce our speakers. We have Howard Twine and Gregory Green. Hey, guys.
Hey.
So without further ado, let's hand this off to these guys.
Okay. Thank you very much. Introductions. My name's Howard Twine. I'm the Senior Product Manager for RabbitMQ and Tanzu RabbitMQ. I have the unenviable task of balancing between open source Rabbit as well as our commercial offerings, and frequently engage with the community through our engineering teams, as well as our end users, our customers. Greg?
And hello, everyone. My name is Gregory Green. I am a solution architect, and I focus on our Tanzu Data Services team, which RabbitMQ is a part of that. So it's a pleasure to be here.
Excellent. Thank you. So I'm going to dive right in here with our friendly spider diagram here, which kind of we're using to kind of like take a look at the landscape for the financial sector in this webinar. Previous webinars, we've looked at areas such as manufacturing and retail. And in today's session, we're going to have a look at how Rabbit fits into the financial sector, which we can break down into many different areas. Starting with just simple accounting and bookkeeping. There are applications that are used to maintain accurate financial records, track transactions, generate invoices, manage accounts payable, and things like that. Financial institutions also use applications, software for risk assessment to assess the various different types of risks, not just credit risk, market risk, operational and compliance risk. And these might involve tools for risk modeling, stress testing, and regulatory compliance. From a trading point of view, firms that are managing trading desks use obviously software for executing the actual trades, monitoring market trends, conducting research, and managing investment portfolios. And these can include algorithmic trading systems and portfolio management platforms. A key aspect in this as well, unsurprisingly, is the ubiquitous customer relationship management, or CRM, systems that are used to analyze customer data, track customer preferences, and generally improve customer service and sales efforts. A growing area of investment within the financial sector, of course, is fraud detection and prevention. And this can range from identity theft, payment fraud, money laundering, and is likely nowadays to involve machine learning algorithms that analyze transaction platforms and identify anomalies. Loan origination and management. Banks and lending institutions use software to process loan applications, assess creditworthiness, and manage loan portfolios as well. These can include tools for underwriting, loan servicing, as well as collection. There are obviously strict compliance and regulatory constraints for financial institutions that have to comply with a wide range of regulations and reporting requirements. And there are software tools to automate the compliance process, monitor regulatory changes, and generate reports for regulatory agencies as well. Obviously, payment processing, including, obviously for electronic payments, including credit card transactions, wire transfers, automatic clearinghouse payments. This includes payment gateways, merchant services, and transaction processing platforms. Data analytics and business intelligence is key as well, where data analytics software can be used to analyze large volumes of data to identify trends, gain insights into customer behavior, look at market conditions and overall operational performance. And finally, asset management. Firms that are dedicated to asset management use software to track and manage various different types of assets, including stocks, bonds, real estates, and alternative investments. This includes tools for portfolio analysis, asset valuation, and performance reporting. So with this in mind, how do you get all of these different disciplines to communicate and share data that's vital to the smooth operation of the business? Well, obviously you could build an event streaming or message bus to connect the many different applications or microservices. That's the obvious answer. But what tools are there to process this data and to make it easy to deploy as well as easy to maintain, both at the core and on the client application or microservice level? Well, you'll be surprised to hear that Tanzu RabbitMQ is used across the globe in many different banking and financial institutions for exactly that. And as we go through this presentation, I hope we're going to illustrate why Rabbit in particular is such a good fit for this and has been for many years. So I'm going to just introduce some of the key concepts of Rabbit. Fundamentally, there are lots of different deployment options for RabbitMQ, from bare metal to really quite complex Kubernetes environments. All of Tanzu RabbitMQ products are built on the hugely popular open source RabbitMQ. We have an OVA, which can be used for virtual machines. We have an OCI image for Kubernetes. There is, of course, our Tanzu application service, or TAS tile for RabbitMQ. And we also have a new generic Unix tar bundle for those people that want to build their own VMs or want to put Rabbit into their own format and deploy it themselves. Now, all of these have the appropriate dependencies, CVE checks that come bundled with them. So you get that peace of mind with these particular packages. So delving a little bit closer into Rabbit itself, one of the aspects that's key to any financial institution, of course, is data safety. And you can start with data safety from a clustering point of view. RabbitMQ is one of the few message brokers out there that provides native support for clustering. This provides both a performance and a resiliency advantage, especially when the number of queues is distributed across the cluster. There are many different ways that a cluster can be formed using a simple config file or discovery plugins for RabbitMQ, for Kubernetes, AWS, and many more. Taking this another stage further, quorum queues is a queue type that provides a replicated data structure, and it's based on the Raft consensus algorithm. Quorum queues really only work with odd numbers of nodes, and one of the nodes hosts the leader replica, and the remaining replicas are followers in that cluster. In the event that a leader fails, the followers elect a new leader, and therefore the message queue continues to function. This provides a robust protection against network connectivities and network connectivity issues and congestion. And these are perhaps the most common issues that people run into when they're building a messaging or event bus infrastructure. Sometimes these kind of failures or connection interrupts can be really costly to detect and disruptive to the business. And quorum queues provide a degree of resilience against this. Moving on from this, the reliability of getting messages from publisher to consumer. Publisher confirms this is a message This is a mechanism that ensures messages are delivered safely. In the event of a restart or a connection drop, messages that haven't been successfully acknowledged can be resent by the publisher. And from a resend point of view, you've got consumer redelivery, which is a flag built into Rabbit that makes it easier for client applications that are consuming messages or subscribing in a pub sub kind of environment. They can identify which messages have been sent previously from this flag. And this allows the publisher to automatically resend or bulk resend messages after an outage to make sure that they're delivered. High throughput, low latency, especially when it comes to large amount of data. And in this particular environment, streams are your friend. Conventional queues offer simplicity, but as soon as a message is read from a queue, it's removed, it's gone. Streams, on the other hand, offer a persistent data structure that performs the same kind of tasks as queues. They buffer messages from producers that in turn are read by consumers. However, they have the added advantage of being an append-only log that can be read many times over. In fact, a publisher can define how long a message will stay in a particular stream. Additionally, multiple consumers can read messages from a stream as many times as they like. Streams were developed to complement the existing queue structures that RabbitMQ provides, and there are quite a few different use cases for that. One of them being large fan-outs to deliver the same message to multiple subscribers. Using a stream for this means you don't need to build a large collection of dedicated queues, one for each subscriber. Sometimes this can be quite tedious, especially when you've got potentially thousands of subscribers. The ability to replay messages or time travel, the non-destructive nature of streams means that consumers can start reading messages from any part of that stream. This is great if an application restarts and needs to carry on where it left off reading those messages. Large backlogs. With Rabbit, it's often said that a happy queue is an empty queue. It's the best way to maintain performance. If conventional queues are filling up and not shrinking, there may be something wrong with the design. And streams, on the other hand, are designed to store messages more efficiently with minimal in-memory overhead. And finally, throughput performance. Rabbit streams can cope with up to about 19 million messages per second, and they can provide latency that's below, well, sort of less than 10 milliseconds typically. And this is exactly why we utilize stream technology for message synchronization in our own multi-site disaster recovery solution that I'll come on to in just a moment. But finally, the stream clients. The standard AMQP client that we have, which is one of our best kept secrets, is that you can use this client to publish messages to a stream within Rabbit, which means you don't have to refactor your code specifically to make use of streams. And this is available in pretty much any language you can think of. But if you want more functionality for streams, and there are quite a few other functions available, we have dedicated stream clients for .NET, Java, Python, and Go. So moving on to disaster recovery, which is another aspect that financial institutions are concerned about, we have a feature that is unique to Tanzu RabbitMQ, and this automates the entire replication process, including messages as well as users, queues, bindings, etc. It provides near real-time replication. It has a very fast recovery that ensures no non-consumed messages, only non-consumed messages are enqueued. It works with either VMs using the Tanzu RabbitMQ OVA, or can be used with Kubernetes. Obviously, with Kubernetes deployments, the RabbitMQ Kubernetes operators that we also provide, they take care of the automation after a failover or promotion. For VMs, and also coming up with our Tanzu application service with Taz, we're launching a new API next month. to be able to better handle the failover process. Warm standby replication can also be used, just as a sideline, can also be used as an upgrading tool as well. Now, security is one of the major concerns that any financial organization has. And RabbitMQ has quite a few security features built into it. It has built-in support for transport layer security. And in fact, intra-cluster security uses mutual transport layer security, or MTLS. We have quite a bit of functionality around OAuth 2. The RabbitMQ authentication backend plugin lets clients and users authenticate using and authorize using a JWT JDOT token for OAuth 2. We've also in the process of rolling out a new multi-audience OAuth 2 feature, which is something we developed for teams that deploy large amounts of Rabbit within an organization. And in many cases, when they're working with an application development team that have requirements for messaging, they will put together a Rabbit deployment and hand that over to that application development team. But of course, according to the OAuth specification, as soon as they do that, they've given away access. They no longer have access to that. So our multi-audience OAuth 2 feature enables users of Tanzu RabbitMQ to hold a spare set of keys so that if any changes are needed after deployment to that application development team or any other part of the business, they can still gain access. And also with the latest version of Tanzu RabbitMQ, that again will drop next month, there is a Federal Information Processing Standard compliant build, or FIPS 140-2 compliant build of Tanzu RabbitMQ. This is a specific Erlang FIPS configuration that uses OpenSSL 3, which gives compliance out of the box for Rabbit. So that's given you an overview of the main features of Rabbit, which is very attractive to financial institutions. I'm now going to hand over to Greg for an even more in-depth view. Over to you, Greg.
All right, thank you for that, Howard. Now, these use cases have been tailored for the financial sector, but many of these challenges are universal. For example, many of our customers start out with synchronous API integration between services that manage a particular business domain, such as accounting data or trading data. Now, I have observed that designing these domains, which is often referred to as domain-driven design, is really an art form that many of our customers struggle to get right. These domain services are often tightly coupled, meaning they become very dependent on each other. And why is that bad? Well, it just becomes hard to update one domain without affecting another. You don't want the innovation of your developers in one team to be slowed down by the backlog of a totally separate team. You want to free up your developers to be able to evolve one service independently. Another pain point is where you have one services that increases the rate of sending data to another service, which introduce performance issues that may have a cascading effect on the infrastructure. And when you got the bosses putting pressure or putting the application teams in the hot seat, everyone becomes terrified to introduce additional load because it's just hard to scale some systems without introducing instability. So to address this, many of our customers are converting from synchronous APIs to asynchronous messaging in order to decouple services. There should be a level of comfort by adding a performance solution like RabbitMQ in the midst to address performance scalability. I've had many conversations with customers in the financial sector where I've either demonstrated or I've shown them some of the public benchmark numbers of RabbitMQ scaling to, as Howard mentioned, 19 million messages per second. The theme is that you shouldn't have to worry about Rabbit's performance scalability. And when you add in Rabbit's clustering and its data replication or its ability to have publisher confirms and consumer acknowledgments with quorum queues, as Howard mentioned, Rabbit just becomes, it just keeps your critical data safe and secure. Applications have enough concerns related to satisfying the various business requirements. They should designate communication concerns to a solution like Rabbit so that they can retire some of that complexity. And Rabbit acts as an abstraction layer to easily evolve the solution over time so future applications can tap into existing RabbitMQ streams. All right. Now, this scenario speaks to a situation where maybe you have a local edge location. Think about integrating data between apps at a local branch that often need to share some subset of the data to some hub data center. Now, believe it or not, we have customers that have had homegrown messaging solutions to facilitate moving data between the edge and the hub. They often express concerns about complexity in terms of keeping these solutions reliable and compliant. With employee attrition, many of them have lost the knowledge in order to maintain these systems. So, similar to the previous design, in this case, we use RabbitMQ to not only facilitate communicating between services, uh, sorry, wait, yeah, somehow it jumped on me. Okay, so similar to the previous design, in this case, we use RabbitMQ to not only facilitate communication between services, but also across different geographical locations. Rabbit can be installed in close proximity to applications at the edge. It also has built-in plugins like Shovel to move data or to federate, which is the copy data, or even disaster recovery, as Howard mentioned, right? To fail over from one data center to a totally separate backup site. And this is all out of the box reliability that you get when you use something like RabbitMQ. Now, many of our customers are also stuck in what I call a scheduled batch ETL world, where sometimes people are making critical business decisions in real time based on stale data that's maybe updated daily or even weekly. Often it takes a fair level of effort to integrate new applications or new data sources. And you are not going to make your database administrators happy if you start pulling more data more frequently for each one of these point-to-point solutions, because it has an increasing performance risk that can shut down mission-critical shared infrastructure such as a database. So to address this, the idea here is to streamline the integration into domain-level services, all backed by RabbitMQ streams. You can eliminate stale data with real-time data, where you can stream new or changes to data that are pushed as soon as the data is available with very low latency. The domain services can expose streaming data in Rabbit as a product, much like a microservices exposes APIs. Streams append-only log conventions scale very well for new and existing applications to replay the data as needed. This reduces the strain on the source system, so data is replayed from RabbitMQ with its high volume support. All right. And also, many times, especially again in this batch-based world, there's very few people that have the expertise to manage or even know the details of system application data flows. They either rely on documentation that's out of date or they bring in professional services organizations to reverse engineer all of the code from time to time. And it may be hard to introduce even the smallest change because these integrations were built to meet a particular project domain, maybe as a short term fix that somehow became a long term solution. And it's just not architected in a way such that teams can manage them easily as a long term solution. So, how can Rabbit help in these cases? Well, many of our customers, as they are moving from batch to real time, they start introducing low code enterprise integration solutions that can be backed by RabbitMQ. If you're already using Java, the Java programming language, and maybe you're using the Spring Java framework that's maintained by our Tanzu division, we have a low code integration solution in the Spring ecosystem. Namely, one of my favorite products is called Spring Cloud Data Flow, where you get a visualization of the data flows and you can create new data flows by dragging and dropping components where at the end of the day, it's just a either a Java Spring application or any language that can run inside of a containers. And you get a visualization of where the data is coming in, how many steps or process steps are involved, and where the data ultimately lands. And there's lots of out of the box Spring components that can move data based on real time changes in popular databases, such as relational databases, NoSQL databases. Or you could even introduce a custom data processing logic with scripting languages like Groovy and Python and JavaScript. And you can also store the output in popular data services, including our Tanzu data services solutions like Gemfire, Postgres, Greenplum, and MySQL, where the communication between all of these connectors are all using RabbitMQ. And if there's not an existing connector, guess what? You can just build your own user defined function, add them to a library of easy to use data streaming applications that can be utilized by just about everyone, not just your developers or your technical experts. And again, it's all facilitated by RabbitMQ. Okay, so also nowadays, I don't feel like any technical conversation is complete without mentioning AI, ML in some way, shape, or form. Now, a reliable machine learning model, for example, anomaly detection to prevent credit card fraud, is often trained from data pulled from many different locations into an analytical platform such as Tanzu Greenplum. Data should go through various stages of analytical cleansing. Uh, when the model is created, data scientists need to monitor the output so that it can be trained over time to continue producing accurate results. Applications that utilize these models do not only need the initial version, but they also need to tap into a ML pipeline that makes sure that the latest version of the model, or they have the latest version, or that they have a particular version that matches a particular application. In all of these situations, you can use RabbitMQ for pulling data to be trained. You can use it to monitor the output of the models for continuous improvement. You can use RabbitMQ streams to save or store the model, and any updates are pushed to, for example, a real time fraud processing application that may be written in Java using the great new project Spring AI, where both the end users and the fraud detection teams get less and less false alerts over time by a continuous pipeline of data accuracy, all facilitated by RabbitMQ. All right, so let's we're going to dive into a demo, and in this case, our demo is going to consist of this architecture. Now, it's basically centered around syncing bank account information across multiple data centers. It not only uses RabbitMQ, but it also uses some of our other data services like Tanzu Gemfire, which is used heavily in the financial sector by companies like MasterCard, for example, for massively low latency in-memory data access. You can use databases like Tanzu Postgres, which is based on the most popular open source database in the world, or Greenplum. You can think about Greenplum as a distributed Postgres that scales to petabyte volumes of data. I have also witnessed that many of the most the mission critical solutions, when they try to pick a programming language, they often are using .NET or Java. And when you utilize Java, our Spring ecosystem again just makes it really easy to incorporate RabbitMQ. So in this demo, it's based on Kubernetes. Kubernetes is not required to run data services like RabbitMQ, but it sure does make the provisioning and the maintenance much easier. We have RabbitMQ in two data centers, Site A and Site B. Rabbit has built-in plugins that, as I mentioned before, that allow you to copy or move data to be replicated for either active or active passive scenarios. The active passive more geared towards disaster recovery, where you can have no data loss. In this demo, we have configured RabbitMQ for active deployment. All of the streaming data is processed in both sites, Site A and Site B. So I want to start by showing you the management console in site number A. So let me go ahead and share my screen. All right, so you should be able to see my screen now. So this is, if you haven't seen it before, this is the RabbitMQ management console or the dashboard. And here you get an overview of the cluster. And you see that I have 3 nodes installed in my cluster. And through this UI, you can review things like the application connections. You can get insights into the channels, which is basically detailed interactions within each one of those connections. You can look at exchanges, which is used by publishers as an abstraction layer for sending events. And you can look at the queues and the streams for applications to consume events. The dashboard also provides details on the health of the cluster. So each one of these nodes, if I go back to the overview, they're all color coded, right? So green means everything's good. If there's any issues, you might see yellow or red when a node or a service is unavailable. And you can also look at the health of the connection. So you see these are also color coded in addition to the queues, right? So again, you get a full picture of the health of the application solution. So for our first demo, what I'm going to do is we're going to demo event streaming in site number A. All data in site A is written using the Java Spring framework. And as Howard mentioned, Spring, RabbitMQ, I should say, it supports many different languages, but we're just going to utilize Spring for Site A because it greatly reduces the amount of code needed to send and receive events from RabbitMQ. Now, there is a Spring source app, which is basically an ingestion point for bank account information. And it exposes a Swagger REST UI to receive bank account data in a JSON format. This data is basically sent to an exchange, and there's binding rules in this exchange that's going to route that data to a queue, which is going to be picked up by a sync application. Now, this sync application saves all of the data into Tanzu Gemfire. In this case, all of the data is in memory. It can be queried from another application, this bank account application, which we have a UI for. So let me show you that. So here's the source application that allows me to submit the JSON payload. And this is the application that allows me to look at the bank account data. So, for example, there is no bank account. For bank A, there's no account 002. So if I do a search, I won't find any. So let's go ahead and let's submit an account. So we'll do 002. And maybe we'll change some other information about this bank. And we'll keep it as bank number A at bank A. So now when we go ahead, I submitted that data to the RabbitMQ. And when I go ahead, now we see that information is available within this application. And if I go back and look at the management dashboard, you'll see some statistics on which queue or which exchanges were used, and you see some data that is in the queues. All right, so that was a pretty straightforward demonstration, right? Nothing special there, but let's move forward. So we also have a RabbitMQ cluster running in site number B, right? So this consists of, let me show it to you. So this is site number B. So again, just as before, it has an overview. It consists of 3 nodes within this cluster. But in this case, we have a plugin that's been configured, the Shovel plugin. So I can access the status of the Shovel plugin that is moving data from site A to site B. And the management console, again, it allows us to see the health of not only the connections, but also all of the applications in the queues. So there is another application that I can show you. This application allows me to see the data that is replicated from site A to site B. So what I did I clicked on the list account. Again, I see all of the data has been replicated from one site to another. It's all using the power of RabbitMQ replication. Okay, great. So what just happened here is, again, the Shovel sent that data from site A to site B. It stored that data into the sink to be stored into the Tanzu Postgres database that we were able to visualize. Great, let's move forward. So now what I want to show you is the reliability of RabbitMQ. A Rabbit allows you to lose one node without affecting any data or without affecting your applications. So in this case, when I have a 3-node cluster, I can lose one of the nodes without having any issues to my client application. And I can increase the number of nodes in my cluster to increase the reliability. So for example, if I had 5 nodes in my cluster, I can lose 2. If I had 7, I can lose 3, so on and so forth, without affecting my data or my clients. So what I'm going to do is I'm going to introduce some instability into my RabbitMQ cluster. And to do that, I'm going to utilize, there is a Kubernetes component, which is called K9s, which gives me a view of all of the services and the applications that are running across the data centers. On the right-hand side are the services that are running in site B, but I'm going to introduce some stability on the left-hand side, which is the services running in site number A. So I can go ahead and I can use this tool to kill one of the services, and I can basically force it to be killed, which basically simulates a crash of RabbitMQ. Now, since this is Kubernetes, and all of these services are managed by our operator, so there's a RabbitMQ operator that maintains a desired state. So when I go ahead and I try to, for example, look at the cluster, you see that node is down. It was being restarted by the RabbitMQ operator, But let's see if we have any issues with submitting a new bank account. All right, so we submitted it. Looks like we didn't have any issues. I was able to find it out. So again, even though I had an outage to my applications, it didn't seem like there was any issues. And look, that node is already back up and running. It's been restarted by the Kubernetes infrastructure, in particular the RabbitMQ operator. All right, great. Now, one more demonstration that I want to show you is this is the final demonstration where we're going to show you the replay capabilities of RabbitMQ streams, a pen-only log. So in this case, as I outlined, all of the data in Gemfire is only stored in memory. So if I stop one of the Gemfire servers and it's going to restart, it's going to lose all of that data, right? And then, but we can, once we restart, so if I stop Gemfire, the Kubernetes infrastructure is going to restart it, and then we won't get any data in the application. But then all I need to do, this sync app was designed such that when it's restarted, what it does is it just starts replaying messages from the stream. So it's going to repopulate the data from the stream to send that data back into Gemfire, so we'll be able to find that data. All right, so let's go ahead. Let's do this. All right, so this is the Gemfire server. So just as before, I'm going to kill this servers. And just like RabbitMQ, it's going to be restarted. So it's going to take a little bit of time to restart. But now as the Gemfire operator is restarting it, right? Again, all of that data was in memory. So now as it's back up and running, if I go back to the UI and let's just do a refresh. And let's put in bank account, I don't know, bank account A002. And I tried to basically do a find. So now there was a little bit of a delay because again, it has to re-establish a connection with Gemfire. So if I hit it again, there's no data there. But as I mentioned, what we could do is we could just restart the sync application. And what I should mention is, here it is, this is the sync application. Now, what I should mention also is the source in the sync application, that data flow, was actually deployed using Spring Cloud data flow. So if I go ahead and there's a dashboard for Spring Cloud data flow that I can show you. So again, this shows me the visualization of this particular data flow. And I can also look at the output of these applications right from the data flow server, which I'm pretty much a fan of. And you see that it's starting to replay all of the data from the streams. So now if I go back and try to find that account, now we're able to find it. So basically it rehydrated that data from RabbitMQ. And that's pretty much all we wanted to show you for a demo. So I hope that you see the power of Spring and to satisfy these various use cases. So maybe we could just open it up for questions at this point.
Excellent. Thank you, Greg. Thank you, Howard. We do have a few questions in here, so let's get started with some of these. The first question is, what are some of the challenges that companies face when using RabbitMQ?
Yeah, I could take that. Maybe Howard, you can piggyback on me. One of the challenges that I see in the field is that many customers, they love Rabbit, they find it's really reliable, but they are challenged with keeping up with the versions of RabbitMQ, right? So oftentimes, I ask them which version do they have. The latest version of open source RabbitMQ was 3.13. And sometimes they say that they're using RabbitMQ version 3.7 or 3.5, right? So that's really one of the challenges, and maybe how you can speak to how we're trying to help them in that area.
Yeah, thanks, Greg. Yeah, you're absolutely right. I mean, it's a classic case of, if it ain't broke, don't fix it. My message bus is working. I'm going to leave it alone. But yeah, there have been a lot of developments with Rabbit over the years, and they continue to be. The team is very actively developing, some quite exciting things. We're in the process of changing the cadence and the priorities that the team have around open source and commercial to make it clearer and easier for folks to be able to upgrade on a regular basis. I think there have been times when we've been a little too quick as a team to send out patches, on perhaps a too regular basis. But let's face it, we have to listen to the open source community. We're part of that open source community, and it's important. That will continue very much to be the case. But a more predictable, more regular release cadence is something that is, very much on the roadmap for Rabbit.
So thank you both. Another question here what are some of the competitive advantages of Rabbit over similar technologies like Apache Kafka?
That's a favorite.
Yeah, I can start out with that. Well, I think the main thing is simplicity of a single platform. A lot of our customers are using things like Apache Kafka or other technologies along with RabbitMQ. So especially with RabbitMQ streams, we're positioning to customers that now you can use a single solution for both traditional message broker use cases and those event log, high volume, transaction based use cases. And I tell you that whenever I see a comparison, in particular about RabbitMQ and Kafka, it's like it's kind of exhausting fighting misinformation, right? Because people always say like Rabbit doesn't have like event streaming. Like it's even today, like in these years, when did we release streams, Howard?
About 2 years ago.
About 2 years ago, like
3 years ago. Yeah.
Yeah, about 2-3 years ago, like people still don't know. So that I would just say like that's one of the advantages. Many times people love the reliability of RabbitMQ. So now you could just take the Rabbit that you love, add some new use cases that people are already using in production for simplicity.
Yeah, and as I alluded to in the presentation, the fact that you can use the AMQP client to get going with streams, that's a massive advantage. You don't have to go back to school and learn a whole new skill set to be able to adopt that persistent data methodology. So yeah.
Thank you, guys. We have a few more questions here. One of the questions was asked if this session is being recorded. I did message the person directly through the questions tab, but just for folks who are listening in, this session has been recorded and will be available on demand. In addition to this recording, we have included the recordings to the 3 previous chats as well. So if you go to the attachments tab, you'll be able to see those other 3 as well. All right, here's a longer question for you guys. I'll read it out loud here. How large can streams get in size? And what is the recovery timeframes of large size streams? Also, Quorum requires 2 servers minimum to remain active, whereas Classic only required 1 server. Is there a way to use chained certificates so you can overlap certificates with expiration dates? So I don't know if you guys see that question that was sent out.
Yeah, do you want to take the first bit of that, Greg? How large can streams get?
Yeah. So streams you can think of as it's a protocol that saves to disk first. So there's really no physical limit on the amount of data that you can actually store in streams, right? So we do generally suggest a performant disk like a SSD, right? So wherever your SSDs can be, that's how much you can actually store into RabbitMQ. And reading that data is basically just it may take some time, but it's just again, it's just the nature of those use cases. Now with streams also, you can keep data since the beginning, all of your data, for example, but it also you can define retention policies, right? So your retention policies can be based on sizes. So if you want to keep a terabytes or petabytes, right, you just configure RabbitMQ to say, keep this much of data and retire and remove the older segments or older chunks. You can also not only define policies by size, but also durations, right? So if you wanted to keep a couple of months worth of data or a couple of years worth of data. So I just think that the way that it manages is very flexible so that there's no hard limits. And when you get those millions of messages per second, right? Since it's a disk first space protocol, right? It won't overload your memory usages, right? So that's how you also get the high volume and you get the long-term storage with retention policies with this solution. Um, and one more thing I wanted to mention is that one thing the team's going to be adding is, once you start using RabbitMQ, once you have massive amounts of data in streams, and it's critical data, you want to have things like backup and recovery, right, built into it, right? Because now you start thinking as Rabbit as another source of truth, right? So things like the disaster recovery component that Howard mentioned are things that the team is continuing to enhance to have your DR strategy to back up that data, however volume of data that you have, it'll be safe across the different geographical locations.
Thanks, Greg. Yeah, there was another part to Stuart's question there, which was around, I'm guessing quorum queues requiring, it says two servers minimum, and we recommend typically three nodes for quorum queues. Whereas obviously, as you're saying, classic queues only require one. And if you're using SSL, is there a way to use chain certificates so that you can overlap certificates with expiry dates? I'm not sure I know the answer to that question. Yeah,
I don't know the SSL question, but I wanted to dive into a little bit about the whole clustering conventions for RabbitMQ, right? One node versus two nodes, right? Because it actually goes to some of the it's an anti pattern now for RabbitMQ to have less than three minimum. You should have three nodes, right? So because the team used to have, there was a convention in RabbitMQ to keep your data safe across multiple services. It was called mirroring. So mirroring was used with classic queues, right? And the team has made, like over the years, have put in a lot of effort to make that more reliant, more reliable. But there is a new sort of modern distributed algorithm, which is the RAF algorithm, right? Where the team basically is retiring some of that complexity that they had. They're just going to utilize RAF. Now with the RAF algorithm, it just the low level details basically just say that you need an odd number, right? So for all of you out there, if you're running RabbitMQ, you're using classic queues, you're using mirroring, and you have two servers, we highly recommend that you move to a minimum of three and start using quorum queues, because 3.13, the latest RabbitMQ, is really the last release that we're going to be supporting mirroring. And I think the data safety improvements. You're not going to have a lot of those. If you've ever struggled in the past with network partitioning with two nodes, right? The answer is quorum queues with a minimum of a three node server.
Yeah. Cool. Thanks, Greg. There's another question from Stuart that I'm very happy to take about IBM MQ version 9 has AMQP 1.0 support. We are rolling out, so Rabbit at the moment will support AMQP 1.0. It's a plugin. I'll be honest with you, that our sort of initial implementation isn't the best. I probably shouldn't say that, but it's not as good as it could have been. And actually, with previous releases, recent releases of Rabbit, we've done a lot of work with containerization and containerization of messages and creating what we call a protocol agnostic core with Rabbit. And what that actually means is right now we're in the process of rolling out support for AMQP 1.0 natively within Rabbit. Not only is that going to give us some performance improvements, in the case of MQTT that we released in 3.12, we saw a 95% improvement in memory usage at node level. I don't know that we'll necessarily get that level of performance improvement with AMQP 1.0 natively, but we will also get all the goodies that you get with AMQP 1 in terms of flow control and things like that. Whether or not it will talk natively to IBM MQ, I'm happy to try that experiment to see whether it will, because I'd be really interested to see. I should clarify that our support for AMQP 1.0 natively is coming in 4.0 later this year. But there's no reason why we couldn't see how good the integration was right now with our AMQP 1.0 plugin.
Great. Thank you, Greg. Thank you, Howard. I think those are all the questions that we had time for today. I know we were running out of getting close to the top of the hour, so I just wanted to use this time to plug you guys. If anyone had any questions on RabbitMQ or anything that was discussed today, what would be the best way for them to either reach out to you or find out more information?
Yeah, you can. We do have Slack channels and various other things. You can get in touch with us through via rabbitmq.com. There's various sort of contacts links on there. You can get in touch with me personally on LinkedIn. Always happy for folks to reach out for me there.
Yeah, for me also, LinkedIn is the best place to get connected with me. So looking forward to having follow-up conversations with everyone out there.
Yeah.
Excellent. And I was looking at the calendar before. It looked like our number 3 version of this webinar was sometime last year. So let's not wait almost a year to get you guys back on to the program. So I do want to say thank you again to you, Greg, to you, Howard. Always a pleasure running a webinar with you guys and seeing you guys from all over the world that you guys are at. So another special thank you to you guys and to everyone who's here in attendance, whether you're attending live or you're attending in the future as a recording. We appreciate the time you guys have spent with us. With that being said, we hope you guys have a great week. This event has been recorded. It will be available after the end of this presentation. If you have any other questions, like we mentioned before, you can reach out to Howard and Greg directly. Thank you all. Have a great day.
Excellent. Thank you.